Okay, so today we're going to look at radiation and radioactivity. So what's the definition of radioactivity? It's the spontaneous breaking up of an unstable nuclei with the emission of one or more types of radiation. So this nuclei is not like a normal, stable, neutral atom. There's something amiss when it's trying to become more stable. So when it tries to become more stable, the radiation is emitted. And we have three types of radiation: alpha, beta, and gamma. So let's take a look at the first one, which is alpha. Now, alpha radiation is when a proton, two protons and two neutrons are emitted from the nucleus of this unstable nuclei. And if you look, that's a mass number of 4. If you look at the periodic table and look for an atom or an element that has a mass of 4, you will come across helium. It's 2 protons and 2 neutrons. So if we just draw here 2 protons, 2 neutrons in here, that is the mass of a helium atom. Helium also has 2 electrons on the outside, but alpha radiation is positively charged. So it's actually a helium that has lost both of its electrons completely. So we can just get rid of that outside there. So it's only 2 protons and 2 neutrons. Because they're made up of protons and neutrons, this gives the atom most of its mass. So alpha radiation actually has a large mass. And therefore it travels slowly. And its penetrating power is actually quite low. So it can be blocked by a sheet of paper, and it can also just travel about a few centimeters in air before it can't travel anymore. Now, the beta is our second type. And beta radiation comes from when a neutron in the nucleus converts into a proton and an electron. Okay, so this has, when the electron is emitted from the atom, it has a negligible mass. It travels quickly and has a higher penetrating power than alpha radiation. Okay, and just like helium was characterized by the 4,2He, beta is its own symbol, which is E for the electron that's emitted, and 0. And that -1 represents the change in the atomic number when this radiation is given off. The last one then is gamma. Gamma is the strongest out of all of these and sometimes seen as the most dangerous. It penetrates very deeply and it's used in cancer treatments as well. It's just as dangerous though as it is beneficial because it can kill every type of cell that is in your body. And it's the only thing that can stop gamma radiation is a thick wall of lead. So it's way more penetrating than the previous 2 types of radiation. How it's used in cancer treatments is that they focus the gamma rays on the cancerous area and the cancerous cells. So they try and pinpoint where exactly that radiation needs to be in order to change the structure of the chemicals that are in our bodies. But if there's only the patient that's in the room, all other nurses, etc., have to go into a different room, so they don't also, they're not also in the environment where the radiation is being emitted. So the gamma radiation, it's not positive or negative, it's a neutral radiation. And what it is it's high energy electromagnetic radiation. Okay, and there are the few points about it. No mass, travels at the speed of light, and a very high penetrating power. Now, I also just want to write in some of the symbols that can possibly be used. So alpha is represented by this symbol. Beta is represented by this symbol. And gamma is represented by this symbol. Okay, now let's look at some transmutations. Transmutations is when one element is changed or turned into another element, and these only happen in nuclear reactions. Okay, so I have a few written out here. So these are all unstable nuclei on the left hand screen, and we have the mass number and the atomic number written down. Across, as we read across the way, this direction, we see that radiation has been emitted. The type of radiation there is our alpha radiation. So we have to figure out what has happened from this point here to this point down here, and what has this element changed into. So to do that, you have to look at the mass number. What's the change in the mass number? The mass number is on top here, 214. Well, what's 214? Take away the 4 for the mass number on top, the 2 protons and the 2 neutrons that are gone. That would be 210, wouldn't it? Because 210 plus 4 is 214, which was the original. So it's easy enough. All you have to do is make sure that the top on the right hand side adds up to the top on the left hand side. Let's do the same to the bottom. So it has lost 2 protons, so it's now going to be 82. Okay, so you can think of it as 82 plus 2 equals the 84. Or you can think of it as 84, take away the 2 protons, gives you 82. Whichever you prefer. So then you look at the periodic table, which element has an atomic number of 82, and you'll see that it's lead. And that's that question done. So you're just filling in the blanks. This one here is a beta radiation. So we have a neutron that changed into an electron and proton. So it's the exact same situation. There's going to be no change on top here. Now, what's 79? It's not minus 1. So what number, take away 1, gives you 79? 80. So remember, the right-hand side has to equal the left-hand side. So 80 minus 1 is 79. So then you look at your periodic table, and you'll find that it is Hg. You can do pause and do this one if you want. Okay, so no change on top, 12 in the bottom there, and it's going to be magnesium. Okay, here we have to figure out what type of radiation has been emitted. So to look at the top numbers, has there been any change? Yeah, there's a difference of about 4, isn't there? Has there been any change here? There's a difference of 2. So seeing the 4 and 2, I should immediately think of my alpha radiation. And also double check that the 234 plus the 4 gives me 238 on top, and the 90 plus the 2 gives me the 92 over here. This question is from the 2022 Leaving Cert, question 5. So this is the exact way of how it comes up in the leaving cert as well. So we're just going to fill it in. This is going to be 222, take away 4, which is 218 on top. 86 take away 2 is 84. Look at your periodic table and you'll get this element. Now down here, this is a mock question. So you see that we're not given as much information here. We have A and Z, they're supposed to be numbers, but we need to figure those out. It tells us the type of radiation, which we're going to need to know what alpha particle, what's that mean in terms of numbers. So I'm going to write it out again. I'm going to just switch in the alpha particle. So now I can figure out what A and Z are. So 241 on top is going to be 237, because 237 plus 4 is 241. And then the 95, well, that's going to be 93, because 93 take away 2 is 95. Okay, so the only extra part there was having to know that the alpha particle looks like this. Okay, that should be okay for you now with radioactivity.